on April 2015 in the ACT math test. This is question number 24. Observation of a certain bacteria colony has shown that its population of cells doubles every 3 hours. Given that the initial population of cells in this colony is about 8 million, which of the following values in millions would be closest to the number of cells in the bacteria colony after 15 hours? So what should we do with this problem? The first approach is to set up a table. The first approach to solve this problem is to set up a table. The first column represents T in hours, and the second column represents the number of cells in the bacteria colony after T hours. So at the beginning of observation, at T equals 0, the number of cells in the bacteria colony, the initial population of cells in this colony is about 8 million. But the observation of bacteria colony has shown that its population of cells doubles every 3 hours. Doubles every 3 hours. So after 3 hours, the number of cells would be 16 million. Another 3 hours, the number of cells would be 32 million. Another 3 hours, the number of cells would be 64 million. After 12 hours, the number of cells would be 128. After 15 hours, the final amount of cells in the bacteria colony would be 256 million. So the correct answer would be answer choice K, اللي هي كام؟ اللي هي 256. Okay? This is the first approach. Alternative approach is to set up an exponential model. طيب ايه الهدف من ان احنا هنعرض الابروتش دوت؟ الهدف ان انا ممكن الانسر تشويسز بتاعتي ما يجيش يسالني عن الفاينل اماونت افتر a certain time t. وارد ان هو يديني الانسر تشويسز كلها exponential growth models او exponential decay models، ومن المفترض ان انا اختار الانسر المظبوطه. فهنا احنا in this approach احنا we will discuss هنناقش how to set up the exponential model. Okay? The relationship between the elapsed time t in hours since the beginning of observation and the total number of cells in the colony after t hours can be represented as C of t equals AB power t. Okay? This is basically the general form of the exponential model. Okay, A represents the initial value, A represents the initial number of cells, the initial population اللي هو كان كام عندنا 8 مليون. اوكي طبعا هو قال لنا ايه؟ as the number of cells is doubling after 3 hours, that means after 3 hours the final amount C of t would be what? Would be 16. Okay, 8b power 3. Okay, so b power 3 is equal to what? Is equal to 2. So b equals cube root of 2. Why? B cubed is equal to 2. But I want to find the value of b, so what should I do? Take the cube root for both sides, so b equals root 2. Cube root of 2, sorry, which equals 2 power 1/3. Okay? Now I can rewrite the equation as C of t equals 8 times 2 power 1/3 raised to the power of t. Now we can multiply the inner power by the outer power. So C of t equals 8 times 2 power t over 3. Okay. To get the number of cells in the bacteria colony after 15 hours, you can plug in t equals what؟ نعمل بلجن هنا للتي بكام؟ التي ب 15. So 8 equals 2 power 15 over 3, which equals 8 times 2 power 5. 2 power 5 is 32. Multiplied by 8, the result will be 256 million. Okay. This is another approach to solve this problem. ان انت to set up an exponential model. اوكي. طيب احنا عايزين نفهم برضو الباور هنا كان عبارة عن ايه. الباور هنا اللي هو تي عبارة عن number of doublings that have been taken او that have taken since the start of observation. اوكي. number of doublings اللي هو كام هنا؟ اللي هو t over 3. هنا I divide the total number of hours the total number of hours by one interval of 3 hours to get what? To get the number of doublings. Okay. So the number of bacteria is doubled each time this amount increases by 1, which happens each time t increases by 3. So the number of bacteria or the number of cells in the bacteria colony is doubled every 3 hours. Come back soon for my next math videos with math. There is always more. Thank you.